You're welcome everyone for class for today. For today's video, we'll be looking at all chemistry formulas you must know for 2022 Jamb exam, but this is the part 2. For those of you that will be seeing this video for the first time, there is part 1 in this YouTube channel. Just look in the last 2 or 3 videos I've done. You are going to see the part 1 of these formulas. In fact, it is good, and I'll advise you to practice the part 1 before you continue from this part 2. And for those of you that have been requesting that I do this part 2, I'm sorry it took a little time, but this is for you. I promise I'm going to start this video by looking at a calculation on gas laws, and that was where I stopped in part 1. The general formula for calculating gas law is P1 V1 over T1 equal to P2 V2 over T2. Now let's look at application. Let's look at this question. 200 centimeter cube of hydrogen were collected over water at 30 degrees Celsius and 760 millimeter mercury. Calculate the volume of the gas at STP if the vapor pressure of water at the temperature of the experiment is 14 millimeter mercury. Now, you can see the formula on the board. I want us to bring out the parameters from this question before we solve. Okay. In this question, the initial volume V1 is 200 centimeter cube. Let me underline it. While the T1 is 30 degrees Celsius. Okay, but it must be expressed in Kelvin. To do that, to turn from Celsius to Kelvin, remember I taught you how to do that in part 1. Just add plus 273. So it will give me 303 Kelvin. Okay, now let's look for P1. P1 equal to 760 minus the vapor pressure of water at that exact temperature, which is 14 millimeter mercury. So minus 14 millimeter mercury. So the initial pressure will be 726 millimeter mercury. Okay. We are looking for V2 because the question says if the vapor calculate the volume of the gas at STP, and we are given the initial volume of, okay, but we are told to find the final volume. Okay, I want you to know that since we are solving at STP, P2 at STP, like standard temperature and pressure, the pressure is a constant, which is 760 millimeter mercury. Take note of that. While T2 at STP will be standard, which is 273 Kelvin. Using our general formula, which is P1 V1 over T1 equal to P2 V2 over T2. Okay, if you make V the subject of this formula, V2 or let's just do that together. Let's make V2 the subject of this formula. So let's cross multiply. So we have P2 V2 T1 equal to P1 V1 T2. We are looking for V2, so we divide both sides by P2 T1. Divide this side by P2 T1. Okay, this T1 cancels this T1. This P2 cancels the P2. So V2 will stand on its own. So V2 now equal to P1 V1 T2 over P2 T1. So we just impute the values into the formula we have. What is P1? P1 is 726 times V1, which is 200, times T2, which is 273, divide by P2, which is 760, times T1. What's T1? 303. So V2 equal to, now if you punch this into the calculator, your answer will be multiply the numerator, divide by this, it's going to give you 172.14 centimeter cube. This will be your answer. Take note of this. All right, so that's an application of gas law. Now, the next formula we will be talking about is calculation of density and molar mass of gas. Very important. Okay, now I want you to know that the original ideal gas law, using this formula, of course, we know is PV equal to nRT. That's the original ideal gas law. Now, the density version of the ideal gas law is what you can see on the board. Okay, yeah, the P stands for the pressure measured in atmosphere. The T is the temperature measured in Kelvin. The R is the ideal gas law constant, and the ideal gas law constant is always 0.0821 atmosphere. Okay, so this another important formula you need to probably just learn in case they ask you to calculate any one of what we have. Okay, we are going to Dalton's law of partial pressure. Now, for this question, to explain this formula, I'm going to use this question to explain how it works. The question says, the partial pressure of oxygen in a sample of air is 500 millimeter mercury. If the total pressure 780 millimeter mercury, what is the mole fraction of the oxygen? Okay, let's bring out the formulas. Let's bring out the parameters, sorry. Now, I want you to know that partial pressure of a gas in a mixture equal to mole fraction of the gas. Let me write it. Mole fraction of the gas times total pressure of the mixture times total pressure of the mixture. Okay, so you can do well to take note of this formula. So the partial pressure of oxygen is 500 millimeter mercury, while the total pressure of air is 780 millimeter mercury. Okay, the mole fraction of oxygen is 500 millimeter divided by 780 millimeter. Hope this is clear. So it will give me 0.64, and that will be the answer. Okay, let's move ahead. The next formula here, root mean square speed of gas molecules. Now, I want you to know that gases consist of atoms or molecules that move at different speeds, okay? And they do this in random directions. The root mean square velocity, okay, which is RMS velocity, is a way to find a single velocity value for the particles. The average velocity of gas particles is found using the root mean square velocity formula you can see on the screen. Okay, now I want you to also know that the URMS here stands for roots, in case they give you a question on this, stands for root mean square velocity, okay, in meter per second, while the R stands for ideal gas constant, which is about 8.3145, okay, while the T stands for absolute temperature in Kelvin, and the N stands for mass of mole of the gas in kilograms. Okay, let's go over to the next one, which is the Van der Waals equation for calculating the pressure of non-ideal gas. The Van der Waals equation is frequently presented as the formula we have on the screen: P plus AN squared divided by V squared, open and close bracket, then open bracket V minus NB close bracket equal to nRT. I hope that is clear. Okay, so the next important formula we need to look at is calculation of heat change in terms of specific heat. Here, in this formula, the Q is a symbol of heat transfer. This is a symbol of heat transfer. In case they give you a problem on this so that you know what to do. Okay? Ym is the mass of the substance, and change of temperature. Okay, this is the change. Sorry, the T, okay, but it's fine. T can be capital letter or small letter. This means the change in temperature. Now, the symbol C stands for specific heat capacity and depends on the material and phase. Remember, the specific heat is the amount of heat necessary to change the temperature of 1 kilogram of mass by 1 degree Celsius. The next formula we'll be looking at is the electric force. This is one of the most common formula in physics, named after Charles Augustin de Coulomb. Coulomb's law, which is represented in this formula on the screen, is an equation that represents the attractive or repulsive electric force of two-point charges. The force is proportional to the square of the distance between charges, as you can see. The proportionality constant that relates force to charge and distance is given the letter K. That's the letter K. You can see here, and is known as Coulomb's constant. So this is another important formula. And then we have the enthalpy or energy change for a constant pressure process. Enthalpy is defined as follows: um, change of heat H equal to change of E plus P change of V. Enthalpy is the sum of the internal energy. We get this, look at what I did here. This is the internal energy plus the pressure times volume. P stands for pressure, P stands for internal energy, V stands for the volume. So use this formula to calculate enthalpy. The next formula we'll be looking at is relationship of wavelength and frequency. Okay, the variable you can see here, this U represent the speed of light. This represents the speed of light. Okay. Why we know the lambda, this is the wavelength, okay, and then this is the frequency. So you use this to calculate wavelength and frequency. Is this formula. All right, thank you very much. This is how much I can take for today. I'm sorry it's coming a little bit late. I know your exam is at the corner. I hope to do more. So please subscribe and stay with me. I hope to probably drop more videos on this. And please, even if you are done with this, your post you pursue me whenever you want me to treat any topic in physics, chemistry for any university. Please do well to make a request and then I'll make it happen. For now, I'm going to say bye.